In this lesson, we're going to look at rational functions. And I'm going to break this lesson up into smaller videos so that you can focus on specific key features at a time. But to introduce it, we're going to explore the graphs of rational functions and look at several different key features. So here I gave you a generic graph of a rational function, and you can see some of the important parts. So we see a vertical asymptote, we have a horizontal asymptote. There is also something called a slant asymptote that will show up in a later video. We are already familiar with x-intercepts and y-intercepts, but an additional feature that rational functions sometimes have are holes. Holes show up as an open circle in the graph, but if you were to graph this on Desmos or on a calculator, you may not actually see that physical hole show up. The graph will kind of continue looking like it's going straight through there, but if you were able to zoom in on that hole exactly, you would see that there's an undefined point right at the hole. So we're going to explore this graphically at first, and then look at how do we find these key features algebraically. In this first graph, I've given you the graph, but also the function equation for it. So this just happens to be the function for this graph, but we're just going to ignore the equation right now and try to get the key features from the graph. So if I look for x-intercepts, I'm trying to find where it crosses the x-axis. We can see it crosses here at -3, 0 and at 2, 0. So we have two x-intercepts, one at -3, 0 and the other at 2, 0. We are also familiar with y-intercepts, so this one crosses the y-axis almost at 1. You might estimate that to be 0, 0.9, so the y value is roughly 0.9. But you're just estimating from what you can see in the graph. So if you said +1, you're relatively close there as well. As I look across the rest of this graph, I don't see any holes that are graphed in the function. So I'm just going to write that there are none. There are two vertical asymptotes that show up. So there's a vertical asymptote here at -4. And when we write the equation of a vertical asymptote, we actually need the equation part, which is going to make that x equals -4. Without the x equals, it's not an equation, and we don't know if that's technically representing a vertical or a horizontal asymptote. So you want to write the x equals for your vertical asymptotes. There is another vertical asymptote at +5. So we have x equals -4 and +5. There's a horizontal asymptote that we see show up. This horizontal asymptote is at y equals 3. And we have the domain of the function. We're familiar with domain. So if we focus on the inputs, what inputs have outputs, we can see that every value here to the left has an output. So we would go from -infinity all the way until we get to this first vertical asymptote. -4 does not have an output anywhere in the graph. So we're going to have a domain that starts from -infinity to -4 with the parenthesis union, and then it starts back up right after -4. It continues in that middle section from -4 all the way to 5, union, and then 5 to infinity. So we are trying to find these key features graphically. There's a second graph for you to explore. If you will go ahead and pause the video, you can try these key features on your own, and then when you're ready, press play and we'll do them together, or you can check your work. All right, so if you've already done these key features, we have no x-intercepts in this graph. That's fine. There is not an x-intercept. There is a y-intercept at 0, -1 point something. We would have to maybe estimate, so maybe this is around -1.7, something around here. Maybe it's -1.8. I can't tell exactly, but we're just estimating. We will learn how to find that algebraically in a moment. There's also a hole in this graph. This hole here is at x equals -4, but we need to estimate what is the actual coordinate of this. So I would say something like -4, comma, -0.9. Maybe it's 0.8. I can't really tell, but we're estimating. Your vertical asymptote is at x equals 3. Your horizontal asymptote is at y equals 0. And the domain of this function will go from -infinity up to -4 because that hole is excluded from the domain. -4 all the way to +3, where that vertical asymptote is, and then 3 to infinity. All right, so in the next few videos, we're going to explore these key features algebraically. So if you were not given a graph, we should still be able to find each of these key features. I'm going to separate these out into multiple videos so that you can go back to them later when you're ready to look at that specific feature.